Thanks everyone for joining today. So yeah, the topic of today's webinar is how to use Coiled Runtime to get the most out of Dask. First, I want to start just a little bit about myself. Hi everyone, my name is James Bourbeau. I'm a longtime Dask maintainer and sort of just active person in the PyData space. In addition, I'm also a software engineering team lead at Coiled. I work with a bunch of great engineers who help work on Dask and the PyData space more broadly. If you ever need to get in touch with me, I'm on various places online. I'm on GitHub, Twitter, LinkedIn, have my various links there. So with that, today for the discussion of the Coiled Runtime, I actually want to kind of touch on three separate topics. I want to touch on, well, first off, what the Coiled Runtime actually is. I then want to talk about why this is useful. What sort of problems does the Coiled Runtime help solve, or at least make better? And then lastly, I wanted to talk about how you can get started yourself today using the Coiled Runtime, whether that's on Coiled for launching Dask clusters or on really any system where you use Dask. So for the first part, what is the Coiled Runtime? So the Coiled Runtime is, in a nutshell, a collection of packages with pinned versions that have been validated to work well together. And we'll kind of unpack that statement a little bit. So I thought it might be useful to just go directly to the runtime source and look at the packages and look at the pinned versions. So the Coiled Runtime project is completely publicly available, open source, all that good stuff available on GitHub. I linked to the GitHub repository for the runtime here. So let me do that. That probably is going to take me out of the slides. Hopefully you're now seeing the runtime repository. Here's where all the source for the runtime is. If I go into recipe, meta.yaml, you'll see the packages. So the runtime is just a collection of pinned packages, and here are those packages with those pins. So in particular, it comes with Dask, distributed, and friends, all the other, or not all, but many other commonly used packages that are used alongside Dask. So we'll kind of talk a little bit more about the actual pinning of these versions in a little bit, but this is really it. So this is kind of the essence of the runtime here. Getting back to the next topic, why? So that's really covered what the runtime is. It really is just a collection of packages that you can install anywhere you would run Python. Why is this useful? So having this collection of packages makes the runtime sort of an easy on-ramp for getting started with Dask generally, or with Dask on Coiled specifically. So Dask itself has many optional dependencies. So for instance, if I go to the Dask documentation, docs.dask.org, go to install, and then go down to optional dependencies, here you'll see a large, zoom in a little bit for folks. Hopefully that's big enough. Let me know if it's not, so you can speak up. So there are a large number of optional dependencies for Dask for different types of functionalities within the project. So for instance, if you want to use a cluster, like scale out from a single machine to multiple machines, you need to have distributed installed. If you want to, for example, use Dask Array, you need to have NumPy installed. If you want to have data access for remote file storage systems, like say on Google, if your data is stored on Google Cloud Storage, or if you're on Amazon using S3 for your storage, you need to have GCSFS and S3FS installed. And so as you can see, the list sort of goes on and on. So these optional dependencies are typically the runtime project and Coiled as a company sort of more broadly sits in this really interesting space. It's sort of where open source is meeting enterprise. So if for instance you're in a small startup or maybe an individual in a research group, you might use Dask and realize you want to read in some Parquet files, and you might try to do that, and if you don't have, for instance, Pyro installed, Dask will print out a nice error message saying, hey, to read in Parquet files, I need you to install Pyro. It'll actually even have a nice little command conda install pyro to tell you how to install it. And for smaller groups or individual researchers, that's or data scientists, that's not a huge hurdle. You can just conda install that command. Usually the person who is doing the coding actually also controls the environment in some of these cases. And it's not a big deal. It's maybe a minor annoyance, but it's not a huge deal. For large enterprises, though, that's for larger groups where maybe there's a whole separate team that manages your software environments, and just saying, "Oh, I want a new package." You may say, "Hey, I'm going to throw this over to the DevOps team. I would like you to install Pyro into this particular environment I'm using." It might be a week or two until that request can actually get done. There might be extra validation and security audits that have to happen for that to take place. So the runtime contains many, not all, but it is certainly an opinionated take on what sort of is commonly used alongside Dask. So, for instance, we get Dask, you get distributed, you get S3FS, GCFS for file access, you get PyArrow for reading and writing Parquet files. You also get other libraries that aren't even necessarily optional dependencies for Dask, but integrate with Dask themselves and are commonly used alongside that. Lots of projects have native Dask integration. So for example, scikit-learn integrates with Dask, and it's often you'll do some cross-validation or some model parameter searches on a Dask cluster. So now whenever you just install the runtime, you'll have scikit-learn installed alongside. So that's the first sort of type of problem the runtime solves. It makes it an easy on-ramp for getting started with Dask. You can just install the runtime and you're good to go for many common workflows. The second sort of problem that the runtime aims to solve is increased stability through large-scale integration tests and benchmarking. So going back to the runtime repository, for instance, so we had the actual, all the packages live in this recipe directory. There's this other test directory where we have benchmarking tests, runtime tests. These are sort of these are more unit tests for the runtime itself. And then we have these larger scale stability tests as well. So Dask and a lot of the projects in the space, for instance, Dask and Distributed, have really nice unit test suites, test coverage, and those are actually quite robust. However, as you can imagine, when you're building a distributed system and you're scaling out to very, very large, thousands of workers are running on a given workflow. Weird race conditions and things that maybe only appear one in a million times will appear quite often whenever you're operating at scale. And sometimes it's hard to capture those issues in the form of unit tests. You really do need to run large-scale tests to actually trigger these types of exceptions in any sort of reproducible or any kind of consistent way. So the Coiled Runtime runs these large integration tests to try and catch those, and so we can provide an additional layer of stability for Dask users. So those are the two main sort of things the runtime helps solve, or two main problems the runtime helps solves. Contains lots of additional dependencies that are commonly used alongside Dask. So you can just install the runtime and go. We also provide an additional layer of integration testing and benchmarking so that we can provide additional guarantees around performance and stability. So that's why the runtime is useful. How can you get started by using the runtime? So, like I said, the runtime itself is completely publicly available. It's actually, we publish our releases on Conda Forge. So you can go here and just conda install Coiled Runtime from Conda Forge, and you can get started today with that. And in fact, I've done that here locally. If I switch over to my terminal, which hopefully you can see, I'll blow up the font a little bit. We are now diving into the live coding portion here. Here we go. So I've created a conda environment just doing this. I did this earlier just to avoid the wait time for installing these packages. But I just, so I said I wanted Python 3.9 and I wanted the Coiled Runtime available. When I do that, Well, the runtime comes with IPython included, so I can go ahead and launch into my IPython session. I can then use really any kind of deployment solution you like to use for Dask. Again, the runtime is useful for really anywhere you're running Dask. I'm going to go ahead and use Coiled because that's a very convenient way to, it makes it easy to launch Dask clusters at scale. So from Coiled, I'm going to import the cluster object. I'm going to then create my cluster. Here I could say 1 worker, 10 workers, 100. I'm just going to say 10 workers here, and that's going to start launching a cluster, a Dask cluster on Amazon for me. So you get this really great dashboard here that's being displayed. Again, I'm just in IPython, so I'm still getting this really nice interactive experience. So I'm seeing where I'm seeing some details about the cluster here. So I'm getting a nice little overview tab here. I can see every cluster gets a unique name. So I get my cluster name, and it kind of gives me some idea about the status. So my cluster is currently scaling. It's sort of provisioning instances. My cluster, the scheduler for my cluster is starting up. Eventually I'll have a dashboard link, which will be nice. I can see tasks that are flying by in my task stream. I also get some information about my sort of the cloud resource aspect of things. So I can see the region I'm launching in is US East 1. That's the default region. That's configurable if you happen to live in Europe or the West Coast of the United States, for instance. And you like your clusters to spin up somewhere else. The default instances here are T3 medium instances on AWS. So those are getting spun up, and you can see here's my 10 worker requests, or my 10 workers that I requested up here. And then down here you get a nice status, basically, a nice progress bar for where the workers are in their launch, in their startup process. So if you looked before, you would see that instances were getting provisioned, we're getting booted up. Right now, we're launching software environments on the workers. We're kind of pulling those Docker images down so that we can have the software available that we want. So by default, Coiled clusters actually use Coiled Runtime for their default software environments. Coiled makes it really easy to create your own custom software environments. If you wanted to use, for instance, the Coiled Runtime alongside with some other perhaps custom package that you'd like to include. Maybe it's some domain-specific thing for a particular, if you're a finance person, maybe you have some finance package that you maintain that you'd like to install as well. Coiled makes it really easy to create those software environments and use them. But if you don't specify a software environment, it'll use the runtime by default. So you can see my workers are now starting to spin up. I've got 9 workers ready, and oh, there we go. All my workers are ready. So I can then say from distributed import client, I can then create my client and attach that to the cluster so I can start submitting computations. I'm now going to actually, before submitting computation, I'm going to go ahead and go over to cloud.coiled.io. And if I do that, I see, oh, I'm pretty zoomed out here. I can go to my cluster dashboard, and nope, here's my running cluster that just spun up. So we get a good sense for the number of workers, how long it's been up, things like that. One nice thing is I get my Dask dashboard right here. I can just click on that little eye icon, and here's Dask dashboard for my cluster that's running on AWS. So if I go back to the IPython session, I can, from Dask.dataframe, I think I ran this earlier just to make sure things work as I expected. So I actually was playing around a little bit just to, let me remove some of that stuff. Great, there we go. So what this is going to do is use Dask's read parquet functionality to read in a public data set on S3. In this case, it's some parquet files containing the New York City taxi data set. Do some operation on them. We're going to do a group by the passenger to get the average tip amount. So I'll go ahead and run that computation. Again, I just had to install the runtime. Pyro came along for the ride there, so I could use read parquet. S3FS came along for the ride, so I could read in data sets from AWS. And there's my computation. So hopefully that gives a nice sense for the easy on-ramp for using Dask at where we're going forward with the runtime. And that's it. That's the demo. I'll go ahead and just close out my cluster. And that's it. We should see that starting to stop in the dashboard on cloud.coiled.io. And that's it for sort of the live demo portion. There was one other thing I wanted to point to here. I kind of alluded to using the runtime in conjunction with other packages. So there is this really nice tutorial on doing that, how to do that easily on the Coiled docs. So you can follow this link and see how that's done. So with that, I'll pause and maybe turn it back over to Adi for questions.
Yeah, there's a question from Bourbeau. He's asking, or she, I don't know, is it possible to install packages to the Coiled cluster after it being instantiated? So for example, after coiled.cluster dependence, right, I can't read it properly. So if you can go to the chat.
Sure, yeah. So for example, yes is the short answer. I will say like the sort of happy path for software environment management is to kind of have your packages sort of all specified ahead of time, spin up your cluster. But there are tools for installing packages after the fact. So it depends on if your package, like if your package, for instance, is some local package you're maintaining. Dask has a upload file utility, like client.upload file, that you can use to upload that source to your individual workers. If your package isn't like some local thing, but maybe on a package on PyPI, Dask also has a pip install worker plugin you can use to say, hey, I want, like anytime you spin up a worker, I want you to install this extra package, whatever it is. Maybe you forgot to install scikit-learn. I'm just using that as an example. You could say, hey, make sure all the workers have scikit-learn installed. It'll go ahead and pip install them on those workers. Hopefully that answers the question.
Yeah, and James, Scott has asked if you wouldn't mind the tutorial that you just mentioned. Could you paste it here on the chat? A link
to it,
absolutely.
Please?
Yeah, totally. And this should hopefully look pretty familiar. You can define a conda environment file, say I want this particular version of the runtime, I want this particular version of Python, and then point Coiled at that environment file. Like you can use the same environment file locally and remotely, which is actually a very nice sort of smooth process. I'm going to go down to the chat and paste this link. There you go. Hopefully that's helpful. Yeah, thanks for asking, Scott.
Does Coiled only work through conda?
Yeah, so Coiled today works with many things. Coiled will work with conda. It'll work with pip. It'll work with Docker images. If you already have those, if you happen to have a Docker image already laying around, that's what you want on your workers, you can just say, hey, here's my Docker image. It also will compose things. You can say, hey, here's my base Docker image, and I want you to actually, in addition to that Docker image, pip install XGBoost and distribute it. And it'll do that for you. It's a pretty slick thing. So if I exit out of here real quick, you'll see I have Coiled inf create, and you can just do, you can see you get, for instance, nice pip conda and container options. So you can specify a requirements file for pip, environment file for conda, and a container, a Docker image as well. So hopefully that answers your question, Scott. Great question.
And the next question again from Apurba, or do I have to create a new cluster if I have a different software environment?
Do I have to create a new cluster if I have a different software environment? Yes, in general, there is like sort of one software environment per cluster. You can kind of mutate that. Like I said before, there's the upload file, there's the pip install worker plugin. So you can kind of slightly, mutate your software environment a little bit. But if you have a whole separate software environment, two different ones that you want to maintain, say for different workflows, maybe you have a software environment for data engineering tasks where you're doing a bunch of Parquet, ETL, and another completely separate software environment where you're doing machine learning predictions on that process data. You would want to have two separate clusters for those.
Cool. Scott, can I, or what the status of bringing my own AWS account to Coiled?
Yeah, so that's a great question. So you can run Coiled on your own AWS account easily. So here is using your own AWS account. I'll go ahead and link to this in the documentation. Or sorry, I'll link this link from the documentation into the chat.
Another question, I thought using conda installs packages locally and then we have to send that to the cluster. Could you tell me if I'm wrong?
Nope, that's correct. Yeah, so your local and yeah, you need to have the packages both installed locally, and Dask will ship that code basically off to the workers. So the workers need to have those packages available as well. So if you want to run some Dask array computation, for instance, you need to have NumPy installed both on your wherever locally is for you. So like in this case, it would be my laptop, but I also need to have that installed on the clusters. So like I mentioned before, with the software environments, you can actually use, for instance, if you're a conda user, this is my personal workflow, but there are other workflows that are also totally valid. I like to keep a conda environment file around that I have locally that I use to install all the packages I want locally, and I just point Coiled to that same exact conda environment file. Coiled will handle taking that conda environment file, installing all the packages inside of a Docker image that you can then use on your Coiled cluster. You name it. So you can say, this is my machine learning library. And then you just tell Coiled, hey, I want to use my machine learning software environment. And it'll pull that it'll build and pull that software image, that software environment, onto your workers for you.
Excellent. So thank you, James. And you can still send questions if you like. We're also we will be doing probably an hour every 2 weeks with James, just kind of a drop-in session that you guys can just drop in and ask questions. So just check out the event page on Coiled, or we'll probably send an email as well. Thank you very much for joining us, and we'll send the recording very shortly. Thank you, James.
Thanks, everyone.